It's all right. Okay, listen up. Here's example number 2. Now, guys, hopefully you're going to see there are three, come on, there are three things being multiplied. I've got 5n, I've got n minus 3, and I've got n minus 4. Three things being multiplied. If any of them equals 0, then the whole thing is true, right? It all turns into 0. So here's what we say. We say, well, what makes 5n equal 0? What makes it equal 0? Well, divide both sides by 5, and n equals 0. Okay, that's one solution, right? That's one thing that would make it true. Well, if n minus 3 equals 0, that would make the whole thing equal 0, and it would be true. So n minus 3 equals 0. We add 3 to both sides, and I get n is equal to 3. All right, that's another solution. Okay? Now, the last one we have is n minus 4. What would make that one equal 0? Now, I know that you can just look at it. You can tell. But this is the way you would do it if you didn't know. If I add 4 to both sides, I'm going to get n equals 4. So the solutions to this equation are n equals 0, 3, and 4. Now, think about this. If I were to multiply this all out, 5n times n minus 3 times n minus 4, what would be the highest exponent of n that I would get, Jack? 3. Right? That would be the degree of this equation. What's the biggest number or the largest number of solutions that I can have to a cubic? It's called cubic when it goes to the third degree. What's the largest number of solutions I can have, Jordan? 3. And in this case, I do. If I were to graph it, if I were to graph this one, it would look something like this. Oh, wait, I'll just 0, 3, 4. Okay? That would be what the graph looks like. It would hit the x-axis at 0, at 3, and at 4. Okay? Now, it does not have to have 3 solutions. It could look like this, where it only hits it once. Okay? It could actually look like this, where it hits it here and here, and only have twice. Okay? Now, it will hit it once. Okay? It has to, because when you have a positive, when the first term is positive, it's always going to start down here, it's going to cross, but it doesn't have to hit it again. It will always have at least one solution for odd degree functions, but that's a little bit more advanced than we need to deal with. Okay? Let's look at the next example.